This set of notes is about chemical and physical changes, which you've had quite a bit of experience in here in the last week or two. So, big idea. Matter has properties that can be changed by physical and chemical processes. By the end of these notes, and hopefully after all the experiments you've been doing, you are going to be able to distinguish between a physical change and a chemical. In the last set of notes, there was a list of physical properties of substances, and physical properties can be observed without changing the substance. You can observe water boiling and going from that liquid to the gas state, but it is still water. You can observe properties like magnetism, you can observe solubility, and that doesn't change the substance. When you observe a chemical property, you actually have to change the substance. In order to observe magnesium burn and become magnesium oxide, you are changing the magnesium from that magnesium to magnesium oxide. So in observing a chemical property, that substance will undergo a chemical change. This slide just reiterates that physical properties can be observed without changing the composition. In this diagram, we see that a sheep is being sheared. That wool is later made into a sweater. So the form of that wool has changed, the color of the wool has changed, but it is still wool. So changing the physical properties of a substance does not change the substance or the identity of the substance. Changes in state are physical changes. We saw this with the stearic acid experiment. You started with a crumbled wax-like substance that was in a solid form. You put it in a hot water bath, it melted, became liquid, then you took that out of the hot water bath and placed it in a cold water bath where it solidified again. So when we're looking at the three basic states of matter, any change from one form to another is a physical change. And this diagram shows sort of a direction of energy for the process of changing the state of the matter. So when going from liquid to solid, you're freezing that, and energy is actually leaving that system or leaving the substance in order for it to go to the solid state. When you're going from a solid to a liquid, that substance is melting, that's the process, and in that process you are adding more energy to that system. In the process of going from a liquid to a gas, we see evaporation or boiling, and vaporization is another term for that. Going the other way from a gas to a liquid is the condensation process. With condensation, you are removing energy from the system, and going from a liquid to a gas, you are adding energy, you're increasing the amount of energy in the system. It's going to be important to understand the direction of the energy through these systems. So freezing, going from liquid to solid, energy is leaving the system, and so that is an exothermic system because energy is being released. Going from a solid to a liquid, energy is going into that system, so that's an endothermic change. With condensation, again, we're going from higher energy to lower energy. Energy is being removed from the system, and so it's leaving the system. It's exothermic. In the case of liquid going to a gas, we have energy going into the system, and that would be an endothermic change. So to emphasize the direction of energy and whether it's an exothermic or endothermic change, with the arrows moving to the left with freezing and condensation, those systems are losing energy. Energy is leaving the system or exiting, so those are exothermic changes. The arrows that are pointing to the right, where we have melting or evaporation, we are adding energy to that system. Energy is going in, so it's endo or endothermic in its change. So again, during chemical changes, the composition of the substances that are reacting change and a new substance forms. So on the left-hand side, when the match burns, it will not resemble the matchstick. It will be a new substance when it is done burning. The copper penny on the right-hand side is reacting with nitric acid and forming a new compound as well. Here are some criteria to determine whether a chemical reaction has taken place or a chemical change has taken place. And you did see several of these clues to reaction happen with the experiments that you were conducting. So if a reaction emits heat or light, when the magnesium was burning, you definitely saw light being emitted there, and that would be an indication that a chemical change is taking place. The silver chloride reacting in the sunlight, changing color, that was an indication of a chemical change. And a change in color can be a tricky one to decipher because we saw earlier that you could dye the color of wool, which is definitely a color change, but that's a physical change. The reaction with the radiation from the sunlight was a chemical change. The production of gas we saw in 2 of our experiments. In one case we had oxygen being produced, in the other case carbon dioxide gas was produced, and then the formation of a precipitate. When the silver nitrate and sodium chloride were mixed, they formed that milky white solid that you were able to filter out. So these are all ways to check to see if a chemical change is indeed taking place. Tomorrow we'll continue the notes with, we'll look at a change of state from a molecular level. So in honor of the launch yesterday of SpaceX's Falcon 9 rocket and Dragon X spacecraft, I'm going to leave you with this short video clip that demonstrates the capabilities of the Dragon to carry people out into orbit. So enjoy.